All right, last lesson in our rational numbers unit. Really, rational numbers are just fractions and decimals, that kind of stuff, but now we just include the positives and negatives. So that's what makes our rational numbers. So this one is on dividing fractions and mixed numbers. So we just got done with multiplying fractions, talking about cross-simplifying, all that kind of stuff. We had to use our integer rules. Remember, our integer rules are the same for dividing as they are for multiplying, but now we're going to put all those pieces together. So get your essential question: how does multiplication help me solve a fraction division problem? So on your notes there, I've got a couple different problems. I'm just going to kind of show us all the problems at the same time here. So think about 12 divided by 3. Well, 12 divided by 3 is 4. But think about 12 times 1/3. 12 times 1 is 12. 1 times 3 is 3. But 12 divided by 3 gives me 4. I get the same thing. Instead of dividing by 3, I just multiply times 1/3. So here, think of 5 divided by 1/4. So think of as we had 5 candy bars, and we wanted to chop them all up into fourths. Okay, that's what's really happening here if I did 5 divided by 1/4. I'm breaking up into 1/4 size pieces, and I would get 20 total pieces. Well, if I just did 5 times 4, I would also get 20. So if you remember back to 6th grade, instead of dividing by a fraction, even if that fraction looks a lot like a whole number, what we do instead is we multiply, but we do it by the reciprocal. We flip that second fraction. So that's how we got 4 over 1, or 4, and we made it a multiplication problem. That way we don't learn a whole new set of rules for dividing. We just do a quick rewrite as a multiplication problem, and we jump right into our multiplication rules. So here's our steps, here's our reminders, and it's very similar to multiplying with the exception of our second step. So number 1 is decide if it's going to be positive or negative using your integer rules. Then instead of dividing, you're going to multiply by the reciprocal. That's your upside down version of that second fraction. Then you go ahead and cross simplify and multiply like you would any other time and simplify your answer. So let's try this one. Last time we did this one as a multiplication problem. Now we're going to try it as division. So first, figure out whether it's going to be positive or negative. I've got 1 negative and 1 positive, so I know my answer is going to be negative. Now, instead of dividing, I'm going to make it multiplication. But the rule is that first fraction never changes. It stays the way it is, but I flip the second fraction. I find its reciprocal. Once I've found its reciprocal, now I'm ready to go ahead and cross simplify. So in this case, 3 and 12 can each be divided by 3. So I get a 4 and a 1. When all of your numerators or all of your denominators are 1s, that's a good sign you've gone as far as you can. 1 times 1 is 1. 8 times 4 is 32. And if you think about it, if I only had 3/8 of a pizza, and I divided that up into 12 tinier slices, it makes sense that I would have some pretty small pieces out there. Next one, -5/14 divided by -10/21. So first the signs. Negative divided by negative is going to be a positive. They cancel each other out. Now I rewrite it. Instead of dividing, I multiply, but I flip. I don't flip the numbers, I flip the fraction. 21 over 10. Remember, we call that the reciprocal. We flip it upside down. And now we're ready to cross simplify. In this case, 5 and 10 can be divided by 5. I always like to give you lots to cross simplify. 14 and 21 can be divided by 7. Gives me a 3 and a 2. In this case, I can't do any more, but you always want to check to see if you can find more to cross simplify. 1 times 3 is 3. 2 times 2 is 4. Some people will actually stop and rewrite what's left in the problem so they can focus on just what's still there and solve all the work if that helps you in focusing on what is actually multiplied at the end. So now to mixed numbers. Same as last time. Change the mixed numbers to improper fractions first, and then we're going to follow all of our regular rules. So 3 times 5 is 15, plus 1 is 16/5. 2 times 3 is 6, plus 2 is 8/3, and the negative just tags along. Now I figure out the sign of my answer. A positive divided by a negative is going to stay negative. Now I rewrite it. First fraction never changes. I change division to multiplication, and I flip the second fraction. And notice I just leave my negative with my numerator. But again, we don't really care about the numerator or the sign at this point. All we're worried about are the numbers and our simplifying. In this case, 16 and 8 can each be divided by 8. Somebody else might have divided by 4, divided by 2. That's fine. You might just have to do a little extra simplifying before you're done. 8 divided by 8 is 1. 16 divided by 8 is 2. I don't see any more that I can simplify, so I multiply. 2 times 3 is 6. 5 times 1 is 5. Almost done. I know it's going to be negative, but it's an improper fraction. The numerator is bigger than the denominator. So 5 goes into 6 one time with 1 left over, and I get negative 1 and 1/5. Last little piece, again, a word problem. Can we figure out what's going on, how to set it up? Here's the biggest key for you. In a division problem, the order matters. You've got to put the right numbers in the right spots. So the key to a division problem, so in this one it says Mrs. Lau rolls out 2 3/4 feet of dough to make noodles. If the noodles are 3/8 of an inch wide, how many noodles will she make? So she's rolling out a long table full of dough that she's going to come back and slice it all up into pieces. That sounds a lot like dividing. The key is in a division problem, remember that first fraction is the one that doesn't change. That first fraction is how much stuff do we actually have. So in this case, 2 3/4 is the amount of stuff we have. We're dividing it into little 3/8 inch slices. In this case, they're both positives, so we know our answer is going to be positive. But we do have a mixed number, so we got to change it to an improper fraction. 2 times 4 is 8, plus 3 is 11/4, divided by 3/8. Now we rewrite it as a multiplication problem. Again, 11/4 doesn't change. That's how much dough we have. But now we make it multiplying times the reciprocal, which is 8/3. Flip that second fraction. Now we cross simplify. In this case, there's only a little bit. 8 and 4 can be divided by 4. And then we multiply. 11 times 2 is 22. 1 times 3 is 3. And then our last step is to change it into a mixed number. 3 goes into 22 7 times. 7 times 3 is 21. So if I took that away from 22, I would be left with 1 left over. So if she had 2 and, okay. Sorry, I had to check myself real quick. So we can make 7 whole pieces, and then we have a little scrap of dough left over. All right, that's how we divide fractions.